So today is our, we're on module 4 of the technical leader, and it's about code smells. It's our first step in refactoring. Basically, until you can recognize that there's some bad code, you're not necessarily going to be able to fix it and turn it into good code. So there's a number of different what Martin Fowler calls code smells. And so we're going to put that right here. He's got this book called Refactoring, and in the he has basically a list of different smells and the refactorings that you can do to clean that up. So I don't know if you've seen this book, Refactoring by Martin Fowler. This is the second edition. It's the version that he wrote that uses JavaScript in the examples. The original is a brown book, and yeah, it's okay. It has its examples are in Java. So yeah, sorry guys, I'm waking up still. So anyhow, if you look in the book, this is inside the back cover. It's got the code smells, and then inside the front cover, it's got basically the list of all the refactorings and what page they're on. So it just is it's a handy reference. He tries to make it as useful a reference as possible. What I've done is for today, there's this website called the refactoring.guru. So this refactoring guru has put together it's effectively the same list as Martin Fowler has, but he's gone and broken it up into classifications, which I find to be really helpful. And he goes and describes it well, and shows he's got the same thing as Martin Fowler, where basically he'll describe what the code smell is, how you get there, and then the various refactorings you might use to clean it up. So this is, frankly, I find this to be easier to use than Martin Fowler's book. So, so this is a good thing to use if you're wanting to learn about the code smells and the refactorings. It's a great reference. But we'll quickly go over all of the different code smells and see some examples. Okay, so the various categories, the bloaters, object orientation abusers, and the bloaters are just basically things that make the code big. Object orientation abusers is when it's an object-oriented language and you're doing things that make it hard to be object-oriented. Change preventers are things that you make one change here and you're going to have to make a change in 3,700 other places, and it's just ridiculous. Dispensables are things that you don't really need. You can just get rid of them. And couplers are things that force the code to be tightly coupled, making it really hard to maintain, because you make a change here, it's going to require changes elsewhere. So the reason we start with code smells is that, like I was saying before, it's a starting point of any kind of refactoring. Once we are comfortable reading code, we have to be able to recognize the good code from the bad code. It took me a number of years to realize that there is good code and bad code, because when I started on the project that I'm on now, the guy who wrote it was a self-taught developer, and he asked me, so did I do a very good job with this? Is this I said, oh yeah, it looks fine to me. I don't see any problem with it. Well, that's because I did not realize what bad code looked like. I had no way to clean it up. I just knew that it took me a long time to make any changes. That's a pretty clear indication that you're looking at some bad code. So yeah, after he left is when I finally figured out, oh man, what I have here is a mess and I need to clean it up. All right, so let's look at the bloaters here. They're, as I say, oversized in many ways. So you've got your long method, and that's effectively when you've got too many lines of code. We'll look at an example of that here. This is my favorite source of examples of code smells. It's the slide project. It's a Reddit. It's an Android application for reading Reddit posts. And if you look at this this do drawer, we go to the end of that. That's 1485 to 2230. I mean, that's it's a few hundred lines of code for this one method. It's pretty crazy. That's all one method. So yeah, this is it's just screaming to be broken up into smaller pieces. And yeah, if you've got a long method like that, it's hard to read, it's hard to maintain. And it's one of the reasons why a couple of months ago, Slide stopped being updated. A large class. Well, we also know this is a God object. It's just got a pile of member variables and methods, and it's the one that you pass around everywhere because it just does everything. And you can see that this class, this main activity, it's got variables that go on for pages, and it is over 5,000 lines long. That's just too doggone long. It's just unmaintainable that way. There's also primitive obsession, where this is where you're using primitive types for an object when it would really be more appropriate and frankly more readable to use a specific object for that sort of thing. So yeah, so basically we look at this member variable called should load, and it's a string. I'm thinking, so what? And it's a static, which means it's a global variable for the application, which is or a singleton, which is another code smell. But basically, so this is a string called should load, and I'm wondering, okay, should load sounds like it should be a Boolean, but I don't know how it's used. So I look in here and I say, okay, there's a function called filter content that uses it. Well, how would that use it? So that's funny. This calls it subreddit. So it changes should load to subreddit. Okay. And then it goes and lower cases it, changes the locale to English, and then does this post match thing. All right, well, that's odd. And then, so then we'll look at this here. And so what this does, it's called base subreddit now. Okay, so we get in here and we've got this get Boolean on it, and we add this other thing. What the heck is this get Boolean? Where is it? So now we've got var1 and var2. I've been digging into this for a couple of minutes now, and I still have no idea what that string means and what it does and how it's used. And if it was in an object, then probably what we could do is have this this function that goes and appends this value and has all these checks, and it would be much easier to understand. So that's I don't need you. That's what primitive obsession is. It's just you've got this basic object that it would be so much easier if it was just instead of using a primitive, you'd use an object to go define it and put constraints on it. A long parameter list. We've talked about this before. That's where you just have too many parameters, and it just makes it hard to like this function here. It makes it hard to pass all these parameters in. It makes it hard to read it, and this would be something where you could turn this into a parameter class, or there's a new Java construct called a record, which would be ideal for this sort of thing. Are y'all familiar with Java records?
Yeah, I this week I remember that in the conference we have this talk about the data oriented programming, where the guy explained it about record, and also this week I have been reading a Java book and about Java 17, and in this book, the author explains how to use Java records. That, by the way, is very similar to. It's actually the same thing that we have on Kotlin, the data classes, right. Where you the same thing. You know, I didn't know about the record because I in my work I had the opportunity to work with Kotlin the last months. And we employed the data classes, you know. And when I saw record for the first time, I said, "Hey, man, I have seen this before," you know. So it's very nice.
Right. Yeah. A lot of people will use Lombok, which is a library, to do this sort of ceremony for a data class. But effectively, what a record does is it changes all this, where you've got to go and take this class, create your member variables, and then create a constructor to initialize them, and then create getters and setters for them. Whereas if you got a record, there you go. You just have to define it, and that's all you need, and you get everything else for free. It's really handy. And so that would be the ideal thing to use for when you've got a big pile of parameters to pass. Let's just pack it all together in a single record, and then I can pull it all out when I get into the class. And then data clumps, which is groups of related data values that you might be able to put into a separate class. So let's see here. So if you go to, I found it right here. So yeah, we were looking at this before, where we've got all this sort of stuff put together, all these variables. Basically, you've got all these different types, and it would probably make sense to stick all of this into a data object similar to a record, just to pack them all together instead of having a bunch of similarly defined objects that are, doing similar things. So let's see, where am I? Here we go. All right. Next, we have our object orientation abusers, and they're just, it's almost object oriented, but not quite. So The first pile of poo is your alternative classes with different interfaces. And that's basically two classes or methods that perform the same function. And I ran out of time trying to find an example of that in here, so I went ahead and just created an example here. So, you know, if you've got your primary object, which is going to be a manage customer function, it's just going to go and return the length of the customer's name. And then my alternative function is going to be get customer size. And it does effectively the same thing. It just is named something different. Well, that's because two different people have come in and written this program and didn't realize the object was already there and just wrote it. And so you can get rid of one of them. That's just what happens. A refused bequest. So that's basically, you know, you've got a subclass that inherits from a superclass, but it doesn't use all the methods. So so for instance, we've got this here. You've got it's got length, width, and height, and a function to get volume. And you've decided that you want to create a square object which only uses the length and the width. And you're going to override what you know, what the volume function does because you're just too lazy to go and rewrite it. But this is a very contrived example, but this is the sort of thing that it's talking about, where it's like, okay, well, why did you inherit from that class if you're not going to use all of it? Perhaps you should have a separate interface that only defines the square thing, and then go and extend it with the third dimension, rather than inherit from it and then throw away most of what the other object does. Switch statements or large if statements. You know, we actually just saw that over here. You got this big old switch statement with a whole bunch of stuff in it. This is a clear indication of you know, you can probably go in and clean that up. Let's see, I found another one in here. Is it? No, it's not. I'm sorry. Right here. Right here. There's another big old switch statement. So basically, you're clicking on something, and based on what you're clicking on, it's going to set some value. Again, this is screaming out to have an object that handles that automatically. And you know, you click on it, and automatically that object starts doing what it needs to handle what you've clicked on. Then you've got temporary fields. That's effectively a class variable that you only use sometimes, but otherwise you just don't use it. So like here again, you got this length, width, and height. And if I'm going to get the perimeter, I get the length and width, and the longest side, I get the length and width, and draw the square. But I'm only going to worry about the height if I'm going to use the volume, which is, I'm sorry, you're going to worry about what you got width and height. So it's like I'm only using parts of it. Like, oh, I probably need to break this up into a couple of different objects, because I'm not using everything that I've defined here. I'm only using it some of the time. So probably I can clean that up and make it a little more readable, break things down. Okay, our change preventers. You know, if you change it in one place, it's going to require you to change it in a whole bunch of different places. So a divergent change is when you make a change in class, you need to also change a bunch of other places within that class. This is really similar to shotgun surgery, where you make a change in one class, and that requires you to make a bunch of changes in a bunch of other classes. So like if we go here, we see we've got this this sync it read, and then we've got this sync it read task, and then of course that depends on the sync it task, and then we've got my sync it read task, which goes inherits from that. So basically, if I'm making a change to this class, that's going to require a change to all, or to this class here. If I'm making a change, it's going to require a change to all of those, because they're all inheriting from each other. So you want to make your base classes something that you wouldn't be changing. This happens a lot if you're doing a lot of inheritance, that sort of thing. You generally want to avoid is-a and use has-a instead. So basically, you'll want to have something use a class instead of be a subclass, generally. Okay, and then parallel inheritance hierarchies. That's a really complex name. When you subclass a class, you decide, you find out you're going to need to subclass other ones. So I really couldn't find a good example of this, but it would be, as if you subclass this task, and then you've got the sync it read. So we've got this read task. Inherits from the task, but then you've also got the sync it read, which it probably does similar things here to the read task. And if you're going to be subclassing from one, you're probably going to have to be subclassing from others similarly, so that it all matches up. And like I said, I couldn't find a good example of it, so sorry about that. Dispensables. These are things that you can just get rid of it. It's just cluttering up the code. A lot of time comments are just in the way. They're not maintained. They can get out of sync and generally not helpful. The worst offense for comment is when you've got commented out code. And again, this has got beautiful examples. Here it is. All this code is commented out. Once we get this working, well, you're never going to get it working because you've shelved it. But this keep that in source code control. There's no reason to have all this commented out code there. Duplicate code. And you can see that there's piles of duplicate code in here. You can see how the shape of things. I look on this little, what's that thing called? Code glance. That's right. So basically, I look on the code glance to see things that, like this is a really similar shape to this, is a really similar shape to this. Just kind of goes slanting in. So more than likely, this is duplicated code. All this looks exactly the same. This is probably duplicated code. So, and you can look in there and see that it is doing very similar stuff. Neutral text does an on-click and got to pass all this stuff in. This has an on-click, you got to pass all this stuff in. probably be a good idea to see if you can break that out into a method just to avoid the duplication. Yeah, that's someone who uses copy paste to build the class up rather than create a subclass. You've got this beautiful object-oriented language. Let's use the object orientation to minimize duplication. A data class, and again, that you can turn that into a record object if it needs to be a data class, or you can go and find the code that uses it and probably stick all of the methods that use the data class and the class itself and put those all together. Dead code, you can see that in here where it's got grayed out variables and methods. Oh no, that's commented out. Finding it all over the place before. Yeah, like this is unused. It's an unused. This is unused. So basically, IntelliJ will show it as gray if it's unused. So yeah, this stuff is all unused. So it's like, why does it need to be there? Just get rid of it if it's not used. Dead code. Yeah, that's what we're just talking about. A lazy class is a small class that does one tiny little thing, and it doesn't need to be in a class. It's only done once, and it's you probably just inline it to make it, to get rid of it. There's no reason to have a whole class that does one tiny little thing, and unless you're in the middle of a refactoring and you're doing that to sort of you're in the middle of cleaning things up. But generally, you won't want to leave a tiny little class doing one thing. Speculative generality. That's kind of what this big old section of commented code is down here, where it says, to do one day we're going to go and use this for other stuff. Like, well, if we're going to do it one day, then one day let's do it. But Yagni, you ain't going to need it until you need it. So there's no sense writing it now for someday when we might possibly need it. It's a great way to clutter up your code and add stuff that is just confusing to people because this doesn't do anything. Couplers. They just make things too tightly coupled, right? So feature envy. This is where you have a method and it's accessing data from another object more than it is from its own class. It's like, well, this wishes it was this other class. So why don't you just take this method and stick it in that class instead of having it go to that class and access all that data, just stick that method in the class. Inappropriate intimacy is when one class uses the data and methods from another class. We talked about this before, where you can the law of Demeter, where I can play with my toys, but I can't play with your toys, and the toys that are mine, I can't go and take them apart. So you want to make sure that your class is only using its own methods as much as possible. An incomplete library class, well, you've got a library, it could be third party or an internal library, and it just doesn't do what you need it to do. So you've got to modify it. A lot of times those are, especially if it's a third party, you can't go in and modify it unless it's an open source project and you're a contributor to it. You're stuck without it. You're going to have to find some way to override it and add your functionality to it.
Similar to inappropriate intimacy is your message chain. It's also called a train wreck. You'll see something like this: A.B.C.D. You're digging deep into the implementation of a class, and so you're needing to. What that does is it very tightly couples all those classes. If you can't really make any changes to the intermediate classes, because it could very well break other places that are referring to this. You also see this a lot when you're passing around a God class, and so you've got to, you're digging into all the data that it needs and all the functions that it does, so that you can get it to do what you need it to. And then there's a middleman, and that would be like this C here. He only exists to get you to the D. You're only using it to get data from someplace else. And it's like, okay, why don't you just flatten that out so that you're not having to go and dig so deeply into the classes. There's got to be ways to clean that mess up. So, the bottom line, if it stinks, change it. These are all the different kinds of code smells that we need to be able to recognize it, and we need to recognize the kinds of refactorings necessary to clean it up. So your homework would be, let's look at the sources from some open source projects. Again, I like this slide class because it's got so many, the slide project, because it's got so many code smells that we can find. Find an example of at least 5 of the code smells that we went over. The slide, let me see if I can find it in GitHub. So, code.com. Ooh, that's right, I've got it in my projects. Here, we'll just say slide on GitHub. Haptic, I said CRAMA slide. Repositories 858,000. Okay, how about we go to there it is. Oh, you did a rewrite. Okay. Slide for Android Wear Alpha stage. Okay, so this is him starting to work on it. Well, heck, I guess I'll need to go and find the original for mine. It's taken too long. So go to slide. There we go. Got mine, and I forked it from here, reddit.com, slide for Reddit. Nope, that's not what I wanted. I wanted the sources, which is, I guess I have to go to the forks. I don't have any forks, I know. I want to go to where, oh, here you go, Haptic Apps slide. There we go. So I will go ahead and put the link for that in the chat. Actually, I'll put it in the Discord. In our discussion for today. This would be our ugly code. So so you can get access to it and dig around in the ugly code and you can find some of these code smells and so you practice identifying some of them. And then another thing, we'll go and put this in the Discord as well, this refactoring guru. Yeah, it's good stuff, helpful stuff for when you're doing refactoring. Basically, he's set up this site so well that frankly, I don't think you even need to get get the book. This is much easier to access. So that is where we're at. Any questions, comments, concerns, discussion?
Well, I'd like to say that I can somehow relate to some of the examples that you have presented, Scott. What I find interesting is that, well, although I until now I didn't have a form to categorize some of the code smells, I can say that in my previous projects I have faced some of them. You know, like for example, the big classes, big methods. You know, the situation about when you said that this inheritance problem. You know, where you are in a situation where you are forced to inherit some classes. And then you see that there are some methods that you don't need to use. So that's a very good scenario. As you said, that it's good to use composition instead of inheritance. So what I like is that your presentation tries to organize these code smells, you know, to categorize, to classify them, and then I believe that by classifying, it's better to learn, you know. So you can create these groups of code smells, and by doing that, you have a way to try to identify them in a better way, you know. So I really like that approach, you know. And very cool indeed. And another thing is I'd like to share an experience that I was working a project recently, and basically the goal was to we have a system where we generate reports, okay, and the goal was to create this system. By the way, is in the past, it allowed users only to generate reports in a synchronous way. So you would click in the button, then it would trigger the request in a synchronous, in a blocking way. Okay, so the communication between the client and the server would block it. You know, basically the goal was to create an asynchronous mechanism. So the user would click in the button to generate the report, and then instead of blocking the communication, okay, the user would request that in a synchronous way. So the client, the user would, from time to time, the customer would poll the server to check if the report was done. So I was tasked with the goal to create this mechanism. And the first thing that I saw when I started to work in this project was exactly what you explained. Okay, so there's a mess. Okay, so the logic, the reporting mechanism was working very well, but it was really hard, you know, to make some changes, you know, because the parts of the code smell that you have explained, they were there, you know, there were long methods, long classes, lots of ifs, the logic was not clear, you know. And the first thing that I did, I said, hey, before doing anything here, before starting to create any kind of mechanism or any kind of feature, the first thing that I believe that I need to do here, I need to refactor. I needed to clean up a little bit in a way that I can start to work on that, you know. So somehow I can relate to your advice. I can relate to the ideas that you are sharing here, and that's really nice, you know. And yes, I think that the homework is good. I have to say that I don't have too much experience working with open source projects. Okay, so for me this is an opportunity to go to this work, to start to explore this open source projects, you know, start to try to understand and learning open source projects. So for me, it's an opportunity to do that and start exploring, start dirtying my hands with open source projects for that purpose of learning how to differentiate good and bad code. And I believe that this is an exercise. This is a practice that you have to do in order to improve. Okay, I have a question though. You at the beginning, you mentioned the book from Martin Fowler, The Refactoring. I know that I'm aware that there are two editions. Okay, so the first edition based, exactly. The first edition based on Java. The second edition based on JavaScript. Right. I like to read technical books. I'm always reading them, and and then I didn't know about this site. It seems to be a very nice site. I have seen a site similar to this, but it's related to design patterns. I don't know if this design pattern website. It's the same thing. Okay, so because it's very similar. This is actually very similar to the design patterns website. So. My question: Do you think that it's worthwhile to spend some time, because I have this book. I started to read the first edition because it's based on Java. Then I put on hold. I couldn't focus because other priorities. But because now we are talking about that, and because now we are focusing on that, my question: Do you think, Scott, that it's worth reserve some time to read that book while working on this homework, while trying to find? Do you believe that it's worthwhile to spend some time reading that book, or do you believe that you can skip that and focus only on this website? What would be your advice for this situation about the book?
Okay, well, if you have the book, then basically the website is based on the book. And what I would do is, the nice thing about the book, frankly, is that you can have it on your desk and it's not taking up screen space. And so you just open up the front cover or the back cover to see the refactorings list or the code smells list. And it's got the page numbers for where you need to go to get the definition if you're not exactly sure what it is. So that's handy. The website has little pictures that sort of explain things well. So they each have their strengths, and the website's free. So if you don't have the book, it's good to have that. So I would say try both and see which one works best for you. But
cool.
I also, like I said, that website is so well done that if you don't have the book, I mean, it's not an inexpensive book. It's, $30-40. So if you don't have the book, the site will get you most of the way there. And you can frankly print off the code smells from the site and have it as a reference on your desk if you need to.
Okay, another question. These slides, are them available on your website?
That's a great idea. I'll go ahead and stick the slides up on the website along with the recording. That's a great idea. I should have thought of that. Thank you for suggesting it. I will do that.
Cool, because
as well.
Yes, because I really like this categorization. This but by the way, these categories, did you get from the book or did you create them? The couplers, all these things.
I got those from the website.
The website. So the website
Yeah.
uses this categorization.
Yeah, Martin
Okay,
Fowler
cool.
doesn't have these categorizations, but the website does, and I found them to be really, really helpful. And so that's why I just basically borrowed from the website and put my thing together based on what he had, and put my own little embellishments in.
Very good, because I at least for me, this categorization is something that helps in the study. You know, you can say, hey, this week I will focus on this category. Next week I will focus on another category. You know, so you can. It seems to me, or at least this is how I see, and a way to better to help in the studies. You know, so you can separate or organize at least your studies based on these categories. You know, so it's I think it's a good thing. You know, this categorization. It's a good way to organize all the approach, all the techniques concerning to different categories of code smell. So that's the first time that I see this categorization. By the way, I have heard about some of them, but that's the first time that I see this grouping of code smell, and I think that's a good thing.
Yeah. Okay. Well, Leonardo, you've been very quiet. Did you have any questions?
Yes, I have one question for a previous session. Can I make the question here? For the first session that I watched the video, reading code.
Yes.
My question is, I watched the video, but I have some difficulty today to read code that is mainly asynchronous. Synchronous code is easy to read for me, but I have a very, I sometimes struggle reading asynchronous code because I don't know where to start. Where's
How to follow the flow?
The first class that I would read to understand the whole thing. Do you have some tip to read asynchronous code?
Well, I feel your pain. That it is hard code to read. For instance, here, do I have it here? Yeah, do that. Let me go share the screen again. What I might do is just go and do an example of how to do that. So, for instance, there's this Refactor First. It's an open source project, and I was wanting to help my friend Jim work on it. So I thought, okay, let's just look for the entry point and see where it works. So I'll just do I'll find the main. And it doesn't really have a main. So how do I run the darn thing? How do I get it going? It doesn't have a main method. Okay, so I just started poking around, saying, okay, so we've got this git log reader. Okay, so who calls that? I can do that, and then just sort of move up the chain and see how that works. So somebody's got to be the one who calls everybody else, right? And so got this one. Oh, this is a test. No, that's not what I need. So yeah, I feel your pain. I understand your frustration and your confusion, because it's like I've got to go and I can't go looking in the tests for this. I need to go in a real function here. So is this okay? So this, but that's a test as well. Well, doggone it. So yeah. Let me. I'll do a session on that next week. How's that sound?
Okay.
because I've got to, I mean, I could stumble around and figure something out right now, or I could save you all a bunch of time and just say, okay, here's what you would need to do if you've got, this is the sort of thing you're talking about, right? Where you've got an event, kicks off another event, and you don't know, how do you follow that chain, right?
Okay. Thank you.
All right, I will do that. That's a useful thing. All righty then. Anything else?
For me, very good session.
Very
Thank
good.
you.
Just one point. So this week, so just to confirm, so our homework is to go to find some open source project, and then on these open source projects, we needed to try to identify some code smells. So that's
Yes.
our goal for this week, right?
Right, and I put a link to the project. It's a GitHub project that has lots of ugly code, so plenty of examples of code smells in there.
Oh, really appreciate that. So we already have some reference. Okay, so, okay, cool. I will start by there, and if I'm able to find that on other open source projects, I'll let you know. But thank you, Scott, to help us in that regard. So we at least we have some starting point
Right.
to do that. Okay.
Yeah, for now, those links are in the Discord. I will go ahead and add them to the Keep Calm and Refactor site later, either later today or early tomorrow. Okay.
Yeah. Okay, Scott. Okay, cool. Perfect. Very good.
All right. Well, I have to, if you don't have anything else, I need to run to my conference, and
I'm fine. So, so you're going to talk today, or
no,
just...
this one I'm just attending. They're actually, it's a conference called No Fluff, Just Stuff. They don't have any vendors there. So it's strictly technical discussions, and the sessions are 90 minutes, or you can have like a half-day workshop, so you can really dig deeply into a concept. So it's more like a bunch of trainings than it is the sort of cursory things that you get at Java 1, where you get 20 minutes or 40 minutes to introduce a concept and give people pointers to learn more. This is where you dig deep into everything that the guy's talking about, and he can give you examples, and you can work on it with him and that sort of thing. So it's my favorite conference, and they're asking me to be a presenter on this, so I'm pretty excited about it.
Oh man, it sounds really cool. Have fun, Joy. Okay.
Yeah, I will.
And let you know if you learn something cool.
Absolutely. All right, guys. You all have a great week, and we'll look forward to seeing you again next week. If you have any questions during the week, please feel free to reach out anytime, okay?
Okay.
Okay.
Have a nice
Scott.
week, you too.
Thank you.
Have a nice week. Thank you so
Talk
much,
to you all
Scott.
later.
Bye.
Thank you.
Bye.
Bye, Scott. Bye, Leonardo. See you. Bye-bye.
Bye, David.